Okay, so welcome all. For some, welcome back, and for few, welcome for this session. Today, we will be looking into about Azure functions, and um, just to start with, I have purposely kept this slide about you all must be knowing about the disaster happening from last few days into Kerala. So please do pray with the Almighty for the quick relief or giving them a patience to deal with such worst conditions. So it's just an small prayer from the Dear Azure team. To start with, let me brief you a small intro about Dear Azure. So Dear Azure is an online community for learning and growing with Microsoft Azure, and we term it as AZ India community for learning Azure in a very cinch way. We do have presence in all the social channels, right from LinkedIn to WhatsApp, Facebook. Today, I will not take much time, and I will give the control to our speaker so he can introduce himself. And I'm very thankful to Mr. Afzaal, Ahmad Zeeshan, for presenting this webinar today and giving his time from his hectic schedule. So let's over to you, Ahmed. Afzal.
Yeah. Hi, can everybody hear me?
Yes, Afzal.
Okay, perfect. Yeah, before we actually dive into the presentation and other stuff, uh, let's pray once again for what is happening in India right now. It's really very sad incident which is going on. But and so yeah, we really should make sure that we keep them in our prayers. And please do donate as much as you can. I remember. A few of the MVPs from my community, they were sharing some of the resources. So basically, in this, can you see my screen?
Not yet.
Let me see. It's How about now? Can you guys see my screen now?
Yes.
Perfect. Okay. So basically, what we're gonna cover in this session, in a very quick session, it will be all about the serverless programming, the serverless concept, and what basically Azure has in terms of serverless offering for the clients, the customers, or for individuals. Basically, serverless, as we all know, it's like a new big term like DevOps, like NoSQL, and similar other terminologies that mostly people don't understand. So I really believe that my overall presentation would be much more for oriented toward the serverless concept, what serverless concept is all about, how we should build the applications for serverless, and then we'll just go ahead and try to understand what Microsoft has in terms for serverless application development platforms, as well as what other platforms have and what are the differences and what actually makes Azure Functions a better platform to develop their applications on, in terms of scalability, in terms of the run times that are provided, in terms of the pricing model, and much more elements, such as, for example, this webinar that we're currently doing. And that this is this is one thing that I really believe distinguishes Microsoft Azure or Microsoft community, because because most of the tools are derived by the industry experts who share their common or actually the personal in-depth experience and expertise. So I really believe that you guys will learn something out of this webinar in the course of an hour that we're going to have this session. I hope that you guys learn what serverless is all about, and similarly how you can develop Azure functions, or whether Azure functions are really useful for you, or you should consider some other services like the Azure App Service. Okay, so my introduction is that my name is Afzaal Ahmad Zeeshan, as Kasam had just said. I am an MVP at C Sharp Corner, Code Project, and Microsoft. Oops, that was not supposed to be here. So I'm basically an MVP at C Sharp Corner, Code Project, and Microsoft. Since like 2 years, I have been really active on local communities ever since I became an MVP. And similarly, I was also working on GitHub and some open source projects. Another major thing, just like I recently joined Dear Azure, I just joined C Sharp Corner for their chapters, and I became a chapter lead for C Sharp Corner for managing Lahore chapter, and I also collaborate with other chapters and other chapter leaders as well. And I'm a software engineer at Systems Limited Pakistan, and in part time I also publish courses for PACT. So now let's go ahead and take a look at what basically serverless actually means. Serverless, in most of the simple terminologies, would be it's like a new methodology actually, in which software engineers, software developers, and other practitioners go about and think about how they should be developing the solutions for cloud for basically the cloud native approaches. Like there have been methodologies like waterfall and so on. So those were the older ones. Then we actually moved ahead towards agile methodologies, where Scrum planning and iterative approaches come in. Then we moved ahead in 2000s when we had DevOps concept. So basically, it was like developers and operations team, and everyone was working in a very collaborative way, and everyone was responsible of what they were doing, and everyone was also at the same time responsible for uh, actually how much can they afford to lose, like how much of the error ratio is okay in the overall experience for the customers. So DevOps was like until 2015 or 2014. Then we started having the concept of orchestrators. Basically, the orchestrators are something like what you can consider to be a platform that manages your low-level servers including web servers or your personal on-prem services. So, with the arrival of orchestrators, uh, the software engineers or the software development teams really considered the requirement or the need of the hour, in which they thought like maybe we can automate the underlying processes, and that is while we are at the time when we were also having the cloud. So cloud was already outside. So basically, the concept of managing someone else's machine for our own self was already uh, demonstrated by Azure, AWS, and Google. And at the same time, what they had in the terms of serverless was that uh, may, maybe the development practices can be improved by allowing or enabling the orchestrators to take control of the underlying infrastructure. So what that helped the software development teams was to introduce a new methodology called serverless, which improves on top of the DevOps approach. In DevOps, basically there are two teams, one managing the dev, one managing the ops, but in actual they are just a single team. In the case of serverless, what happens is that you mostly just focus on the business side of the development. What that means is that you only write the application, you write your tasks, you write your function, you write your features, services, and so on, and you don't actually manage the underlying architecture or the infrastructure that has to run those applications. You maintain you maintain a very specific kind of what you can say. You maintain a specific sort of SLA that you make an agreement with the cloud vendor, and you pay for the service. You like It's like an offering where cloud vendor cloud vendor tells you that, okay, you pay me for this much and I'll make sure your application is up 99.9% or for 20,000 clients or so on. So that is the concept where serverless actually comes in. So operations is all managed by the orchestrators or the cloud platform provider. Serverless offerings have been provided by many different vendors. Serverless has been implemented in Azure as Azure Functions. AWS has the Lambda, Google Cloud Functions, and Alibaba Function Compute. These are merely a few of the offerings that are made by different cloud vendors. The thing is that serverless only works on the server, where you don't actually have to manage the operations side of the story. Why? The reason being that if you try to implement this concept on your on premises, you are still managing the servers, the infrastructure, the networking, and the upgradation of the machine or the software. So in a way, you are doing serverless in a DevOps environment. So serverless basically enables you to write the code, push it, and have the cloud platform provider or the solution provider manage everything for you. So that is exactly what we are going to see in just a minute in the Azure portal, and we're going to discover how we can develop serverless software and how we can leave everything to the cloud platform such as Azure in this case, and to to just try to take uh, just how to envision like how Microsoft Azure can support you in scale in the terms of scaling, in terms of security, in terms of resiliency. Now, if we just go ahead and shorten our overall domain of this just to Azure Functions. So basically, Azure Functions is the serverless application development platform, which we have just been talking about since like few previous minutes. The serverless application development platform, it is based on the Azure app application, Azure app service. The app service falls into the PaaS offering by Microsoft Azure, and this offering enables you to deploy your applications, deploy your custom solutions written in any of the runtime, any of the language, for any of the purpose, for any of the scale. You can develop the application and just deploy it on the IR app service. What already was provided and supported in the IR app service was that you can create your own application, you can deploy it, you can scale and unscale it as needed. With the invent of Azure Functions, what happened was that you were no longer responsible for scaling the applications or maintaining how it actually functions, or even changing the version of the runtime that you are currently using, because everything will everything will now be managed by the platform itself. The difference the difference that this creates is that Azure application server service does include, and it does come with an auto scaling feature, but even the auto scaling feature requires you to monitor and modify it to some extent. What serverless approach requires you to do is that you leave everything to the orchestrators, and you let them to decide how they want to proceed, how they want to scale, how they want to operate your application. And like for example, which which of the services requires an extra instance of the application, and which of the portions of your service does not require any such. The Azure application service, the app service, basically came with an app service plan or the app service environment previously. What that provides us with is either a either a dedicated or a shared plan where we can deploy our services. The plan basically was a way was a way to tell whether your application will be using single core CPU machine, dual core CPU machine, how much RAM will be utilized, whether you are provided with the support of custom domains, and so on and so forth. With the advent of Azure Functions, what Microsoft did was they went a step ahead and they introduced a consumption plan. The consumption plan basically is a plan in which you make a commitment, like Azure will be charging you for the number of requests that your users make, plus or multiplied by the amount of time each request takes. So it's like the app service plan is like a monthly commitment. You make a monthly commitment and then you pay for that. So you get like a dedicated CPU, you get a dedicated RAM, and your application can easily float around. Your application can scale, your application can do any kind of task. It can even keep all the resources or all the binaries loaded inside the memory for an improved runtime and an improved performance experience for the customers. But in consumption plan, what happens is that each time your users are going to make a request to the Azure function, Azure will load the function into the memory, and then it will try to access and then it will try to execute the code which the user was trying to access. And once it is done, it will try to deload or deallocate all of that. Normally it takes less than a second, but still it will be counted as like a second of a runtime plus or multiplied by the amount of RAM or the CPU that your application is using. So you need to do the math, or you can just visit the IR pricing calculator and check for yourself how much of this is. Sorry, I should just turn this off. So and the consumption plan basically allows you to reduce the upfront cost, and only pay for the amount of memory or the resources from Azure that your customers are using. So far, Azure did try to provide runtime support for Python, for Bash, for executable files, and for everything. But with the second version of Azure Functions, they have limited the scope of this to C Sharp, Node, and most specifically the F Sharp or Python support will come soon. So this is basically the overall rundown of what Azure Function is, what it does, how it supports, how it runs, and what languages or the runtimes can you use on Azure Functions for development right now. Now let's see that we have, just imagine that we have written an Azure functions, so an Azure function so far, and now we need to trigger it, like we need to execute it in a very basic or very common applications service, like for example an app service. What you do is you basically uh, send a request to the domain that to the domain name that you have mapped or you are using, and what you do is like you consume the web application, because it's normally just an enterprise or a basic or custom application. In the case of IR functions, what it is that IR function is no longer an application, but IR function does have an endpoint. So the concept of actually consuming an IR function is to trigger it, because the concept of IR function is much more oriented toward the event-driven programming practices, and you and the thing is that you trigger the applications in an event-driven approach. So when something happens, your function will be triggered and it will perform some operation. So for example, the trigger, the basic or the most commonly used triggers in the IR function are the HTTP trigger, which means that your function will be triggered by an HTTP request. Or there are some triggers such as blob. The blob concept would be covered in our Azure storage talk, which I'm not sure, but Kasim can help us out with. Maybe it will be done in the next week or so, and you can join us in that to understand how blob or queues and the tables function in the Azure environment. So similarly, the blob triggers enable us to trigger the function whenever the user has uploaded or stored a blob. Similarly, a queue trigger is an event-driven practice. Whenever a user has saved a message inside a queue, our function will be triggered and it will execute something, and so on and so forth. So basically, if we just try to trim the concept down, we see that the IR functions are merely the inputs. The triggers are the inputs to the IR function. So IR function can be executed by a trigger, which we have. Actually, the list is really very long. You can have several triggers. You can even build your own custom triggers that will be triggering the IR functions, or you can use the webhooks to trigger the IR functions. We won't be going that much deeper in the concept of this, but we will try to demonstrate one of the trigger in the portal. And since we have just talked about what an input to the IR function is, let's go ahead and take a look at what an output from the IR function looks like. So the output from the IR function can be taken in a binding. The binding basically tells the IR function where it has to submit the response. Since the IR functions that we mostly work with are in C Sharp or Node.js. Every function like most likely returns something unless they are void. So the C Sharp script files for the IR functions, we can use any kind of data that we can return to, such as the blob, queue, table, or HTTP. Now the thing is that the return type of the function becomes the binding. So like for example, if we have to store something in a queue, like let's say a user comes to our function, they start an order, they create a job, and now we have to store that job into the queue. So what we will do is we will create a mapping for the queue. We will set the attributes like the connection strings and other stuff. We will create the return type equal to the queue, and then at the end of the function we will just use return, the basic C sharp, let's say the C sharp return or the Node.js return function, return keyword, and we will just return the object, and the IR function will take care of the internal bindings or the mappings that it has to take care of for storing the object inside the queue. Similarly for the table and for the HTTP. But the thing about the HTTP trigger is that HTTP trigger doesn't store the value anywhere. It merely returns the object inside the browser, or for any API consumption channel that you're consuming. So that is a really very easy way in order to consume your application functions, the web APIs actually, because you are able to send a request via HTTP to create a job to store something in the queue, or you are able to send a request via HTTP and I get a response via HTTP as well. So there are different ways in which you can utilize the Azure functions to trigger them, or to get a response, to create a batch job, to perform an action, or to even store something. Like for example, a very basic of the prototype that I built once was that whenever the user stores some information in the blob, we add we run a task to crop the images. We run the task to resize the images, and then we store all those images with different naming in the blob once again. So what this actually benefits us in a way is that the user doesn't have to wait for as long as we are trying to resize the like for example, if we have to create 10 or 15 different sizes, or we have to compress the images, we have to scale it, grayscale it, and so on. So the user don't have to wait for all that. What user only will be doing is that they will merely be uploading the file and then getting a response like, okay, file has been created. And then our backend code, such as the IR function, will be responsible for doing all that hard work and then storing the images in the blob as well, so that our users can consume them. The development, there are different ways in which we can develop the application for the IR function. IR functions basically are scripts. In the most simple definition, it's a very lightweight task that can be executed independent of any other dependency. Like for example, it can be a very simple C sharp script that does not require a whole lot of .NET framework to be injected. It can be a very simple Python project that does not require a lot of dependencies or runtime such as Django or Flask to be first loaded into the memory and so on. So that is why the development can be done right from the IR portal. You can modify the script, you can change the code and then debug it by sending a test request to the IR function. You can do a hardcore development inside Visual Studio, package the function, and then upload the functions to the IR function as well. And that is pretty much done in a very enterprise capacity. We won't be taking a look into that part because we can decide for going into the depth of development with Visual Studio in a separate webinar. And for the time being, we'll just take a look at what or how a very simple IR function can be created in the IR portal. And lastly, since IR functions are based on the IR app service, we can do CUDO based or other advanced backend console like development, such as the Visual Studio Online or any other thing that we can see, like we can go ahead and tweak the function. But this is not a recommended approach because the first thing is that that this is not version controlled, so you can always mess up with something. Then again, the Azure App Service might give you some tough time in the development or even tweaking of the Azure functions. My recommendation for the development of Azure functions is development with Visual Studio, because Visual Studio gives you intelligence. It gives you ability to debug the functions before testing them on the portal, because each request that you're going to send will definitely be counted against the quota that you're going to get. And then likely, if you just want to go ahead and change like the message that is printed, you can just do that from the IR portal straight away. The pricing, as we had just seen, is the IR functions come with a consumption plan. The consumption plan, as we just discussed about, could you cover cold start? I'm sorry, I didn't. I'm sorry, I didn't get your message. Could you cover cold start? Um, like, what does that mean actually? The benefit of what? Please do type the message and I'll check it. So the consumption plan we have just seen in the previous slides, that it basically calculates the consumption that your function is doing on the Azure resources and then charges you a monthly bill for that. And the app service plan basically is a monthly commitment. In the consumption plan, this must have been under the consumption plan. But anyways, the consumption plan gives you free 1 million requests quota per month. So like basically for development, for testing, or for startups or similarly, you can have 1 million free request quota per month. So that's like a really very easy and nice way to get started with the development and testing of the AI functions. So now let's go ahead and take a really very quick demo in the IR portal, and let's see how we can create a function and how we can like utilize one of them and send a request to them. So if you guys have any question, please do let me know and I'll try to answer. And I'm still waiting for Rukhsar that you try to tell me what benefit were you looking for so that I can help you out with that. And Kasam, are you there with me as well?
Yes, yes, Afzaal.
Okay, please do let me know if I'm like in a very fast pace so that I can slow down a bit.
No, no, that's absolutely fine. Ruxar, if you want to ask any question, you can unmute yourself.
Yeah, please. That would be amazing as well.
Yeah, if anyone has any queries or concerns or any questions, please unmute yourself and please ask to Afzal before he starts the demo.
Yeah. So like every other service on the Azure portal, we are provided with a pricing tab where Azure or Microsoft explains everything related to related to that service, uh, one at app level or individual function. Basically, the offer is for the service that we're creating. Like for example, the concept, Rukhsar, we have in this service is that you can say that it's basically on the app level, not the individual task that we run. It's on the application or the service that we create. We can create unlimited number of functions, and I'm not sure it would be like around maybe 100 functions limited to a subscription, but so it would be like 100 million requests for one subscription only. So the 1 million request is for one function application, and the internal functions or the tasks that we create or consume, they are counted toward that 1 million request. Does that clarify?
Yeah, thank you, Afzal. I think so. These the request here the Microsoft is offering. It is a function app level, not individual function we added inside a function, right? That's correct, right?
Exactly. Like for example, if you see my screen, you can see that Azure functions pricing. And so let me just close this. Azure function pricing. So Azure function consumption plan is built based on per second resource consumption. So basically, it's the resource consumption and not the task execution. So 1 million requests, and typically I think it's like 1 million requests counted at 1 second each. So if there are, I'm not sure of this, but I really think that if there are like every of your request takes like 2 seconds, so it might cut short to by half or so on or so forth. Because if you see over here, 1 million requests and 1 million requests and
I'm
400,000.
also asking, yeah, microservice is not mentioned. It is at function level. If, for example, I have the function app, and inside a function there is a 10 function.
Yeah.
It is the 1 million request for total that we are executing
So
inside a function app or individual function app.
no. It is for the overall Azure function. So it's like if your first function takes like 500,000 requests, the rest of the nine will have to accommodate in the rest of the in the rest of the five, in the rest of the 500,000 actually. So it's
Okay.
like 1 million requests for the overall function. But then again, if you try to look at my screen, you'll see that there is another terminology over here, 400,000 GB second. The GB second actually states the amount of RAM actually that your application can use per second. So it's like if your function runs, it's just like a bit of a mathematical, but I'm really very sorry I have to do this. So if like your function runtime executes takes 1 second and has like 100 MB of RAM consumption. So that will be like 1 second will be deducted from the 1 million request and 100 MB will be deducted from this 400,000 GB per second grant. So it's like something like that. It's a very huge function that is calculated by the amount of RAM that your application is using, by the amount of CPU frequency it utilized, the amount of time it ran, and then they calculate what is the quota. So it's not like 1 million requests will be served if the function takes 5 seconds or 10 seconds as well. So if your function continues to grow or continues to execute for longer than that, then the grant will be lesser. So
Okay.
is that okay?
Yeah,
Per-
thanks for clarification.
Perfect. So yeah, I think this pricing detail has really very good explanation. This resource consumption part has something really very helpful for that, and you can definitely check this part out after or right away. So let's just head over to the functions tab. I should go ahead and create a new test function for this. Functions app. Let's go ahead with the functions app, and I'll be leaving everything to the default, to the most of the stuff to be default. I'll create it and I'll just be demonstrating how easy it would be to write any function application, and then I will also try to demonstrate how like you can modify the functions to like mimic some of the best practices or some of the other different areas of software engineering, such as how you can shift and lift the web APIs. Like a web API is simply an HTTP trigger like application. Your users come, they trigger something, they get a response, and they go back. Similarly, you can just lift and shift your currently hosted web APIs, and you can make them function applications. So let's just I hope this name will be available, dear Azure. Okay, so don't worry, Kasam, I'll delete it afterwards. So yeah, let's just create a new one. We're gonna go with consumption plan and app service plan. I'll just go ahead with the consumption plan. We just specify the location, and the rest of the stuff is all similar. Create new, use existing, and the storage name, the application insights. These are just extra features that are provided by the Azure platform in order for us to monitor our service, like application insights for the monitoring, the storage for logging, and for other purposes, and rest of the stuff like which of the operating system we want our application service to be running on, Windows, Linux, or Dockerized environment, or so on. So I'll just leave everything to the default. I'll use a name. I'll just create the function. While the function is being created, if you guys have any question, please do ask.
Yeah, there are three options to select the OS, the Windows, then the Linux, then Dockers. So is there any
Mhm.
difference in pricing if I go for the Docker?
Yeah, there is a huge difference because as we just discussed in the previous slides that Azure Functions is based on Azure App Service. So that is exactly why it was asking should we use an app service plan for Windows or for Linux. The Linux pricing is really very low because of the operating system costs that the underlying platform doesn't have to incur. So Linux, and then I haven't yet tried the Docker pricing, but as far as Windows and Linux are concerned, the Linux pricing is really very down, and at the same time, the performance of the Linux app service is huge. It's a really very huge difference in terms of performance when it comes to Linux and Windows. And so it's like really very beneficial if you consider using the Linux app service environment. But then again, you will be limited by several features that are offered on Windows platform. So I think it's those features that you should try to enlist first. And I think that this topic can be covered well in one of the app service webinars if Dear Azure has one, or we can check with Kasam and organize one for ourselves. So now that our resource has been created, let's just go ahead in the Azure function. So far, basically it's just a portal that tells us what has been created, what we can do, and what other offers are there. Like we can just go ahead on the portal. It will say that your Azure Function app has been deployed, it is up and running, and so on and so forth. So now the actual part comes when we have to create a function, or we have to create the proxies or slots. Proxies or slots are somewhat advanced kind of topics where, like, if you have to stage your environments or for testing and for other purposes, you can utilize the functions. And then some of the other advanced concepts come when you have to actually uh, configure the platform. If you guys have ever worked in the application service or the app service environment, you will see that these settings all come from there. All of these offerings that are available, like the authentication, or let's say this console or advanced tool, like we just saw that we can configure this as well. All of these come from the app service, the networking, SSL, custom domains. Each and every single of these comes from the app service, and Azure function provides us some of the settings on top of that. The app service settings start from here. So in a similar manner, if, like, for example, we have a function where, like, we try to access the SQL Server database, a best practice is that we should never have our connection strings encoded or embedded in the code. Even in the version control system or anywhere, we should not have that. So in a similar pattern, application settings can be used for that. Networking can be used to prevent access, and so on. All of these services have different benefit and different features that you can use in this overall scenario. One thing that you will see over here is is that since we chose a consumption plan, we're no longer able to maintain and manage the app service plan. However, if we had chosen the app service plan, we would have gotten this, and we would have not gotten this consumption plan. So these are the choices that you have to make, and as you can see that you cannot go from one to another and so on. So I really think that this is a choice that you guys have to make in order to, like, select which is important for you. The monthly commitment, or are you able to write the functions in a very appropriate and efficient manner in which it's really very easier for you to manage the costing, because you will only be charged for the amount of time that your users are consuming, and not for the time that your application is sitting idle. So let's just go ahead and inside the functions tab, create a new function. So far we don't have any function. We can create a new function. The function basically is a task that we want our runtime to execute. A good practice in the Azure functions is to make sure that your function runs like for maximum of 300 millisecond or 500 millisecond, and must never go above 1 second. But once again, if we talk about the serverless approach, there is no requirement for your function to run less than 1 second. Because when we were studying the serverless concept, we saw that the serverless only focuses on the development side of it. It does not focus on the operation side of it. And the 1 second runtime, or these runtimes mostly come when you have to take a look at the operation side as well. So in terms of serverless, there is no requirement. But in terms of Azure functions, or for any other serverless function deployment platform such as AWS Lambda, there is one recommendation that you should consider that your functions run for as little time as possible because of the costing that is involved in the overall process. So as we had just discussed, the runtime so far, okay, so the runtime so far is C Sharp, F Sharp, and JavaScript. JavaScript basically being the Node.js framework, the F Sharp and C Sharp. These are the these are the runtimes that are supported by Azure Functions second version. In the first version, there was a huge plethora of the platforms and frameworks that you could select from. Similarly, the scenario, what you want to do, the core functions, you have some webhooks, basically HTTP triggers, data processing, sample, IoT hub, monitoring, and these are different cases that you might want to write a function for. Such as, for example, you might have some IoT projects that you want to ingest data from. So IoT hub might have a sample application that you can get started from. You could do some data processing. So a very typical scenario would be like, for example, at night 12 a.m. you just want to run a job that triggers, like for example, your data warehouses and produces the reports, and so on. So there are different several scenarios that you can look into and try some of these. So, but however, we'll just go ahead with the HTTP trigger because that will be much simpler to understand, as well as it will be much simpler to trigger and to perform as well. So we'll just go ahead, choose C Sharp or JavaScript. C Sharp will also use the CSX files, which are the script files for the C Sharp, and it does not contain or require a full-blown .NET framework. Similarly, the JavaScript will be run in the Node.js runtime, and when I'm not doing C Sharp, I'm mostly found in Node.js, so it's really a very hard choice. So I'll just go with the C Sharp. The name of the function that you want, in the IR portal, you can change the name as well. But once you will be developing your solutions with, let's say, Visual Studio, you will be given a full flexibility of managing everything from the templates. And Kasam, I really believe that we should do one of the Visual Studio session as well, so that we can demonstrate to the community how they can build their solutions, their IO functions right from the Visual Studio as well, and how much flexible Visual Studio in terms of the development and debugging is for the overall process.
Sure.
I'll just say I'll just call it hello function. Then comes the authorization level. Authorization level basically is the authentication. It's much more of the authentication side, not the authorization, but it's like a blend of the both of the concepts. So it says that whether your application function is accessible from everywhere. So if you just put it to anonymous, anybody can access the function. If like you want that your application will be accessed by a specific function-based key generated, then you can select this. Otherwise, it's an admin, which means that the whole function apps key will be used for this. I'll just leave it to anonymous so that you guys can also try to hit it once and see how it functions. So I'll just go ahead, click create. This will just go ahead, create a new deployment inside the same app service, and will provide us with a runtime where we can check what the function is. We can edit it, we can see the logs, we can add some other stuff into it. I'll just leave this all to the default just to make sure that it compiles and it functions as well. So as you can see, if I just try to zoom in a bit, on the left side we have view files, which are basically the files, as well as the tests if we have written some. So these are, and then at the bottom of the page, we have logs and the errors and warnings for the compilation that we have just triggered in the portal. So we can go ahead, view the files for this function. There is a function.json file. This basically specifies the structure of the function. And as you can see, we had just discuss the bindings, the triggers for the application. So this is an HTTP trigger, uh, and its direction is an input. It's an input type, and the methods that it supports are get and post. So these are the two methods that our users can use. The name of this parameter will be request. The authentication level is anonymous. So it's like the configuration for our function that Azure will be using in order to execute it and to run other sort of actions onto it. Similarly, we have direction out, and the type of it is HTTP. So it's another kind of binding. It specifies that whenever the function returns something, you you are responsible for generating a response for that HTTP content and then delivering it over on the wire to the clients. So that is pretty much it for the function. It can get as much complex as you want, and it can stay as much simple as you might want it to be. And you can add multiple functions separately, one for get, one for post, one for port, and so on, instead of having to have one of the functions manage everything manage everything for you. So the code basically is that it requires us to pass a name value in the query string, uh, and it's just gonna say hello to whatever the name that we have just passed. So I'll just click run for it, and as you can see, the debugging properties over here allow me to send a request body as well. So it's very flexible way for you to quickly just run the application, debug the application, and see how it is going on. If I could just extra, if I could just pull it up a bit, yeah, there. So if you can just see that this was the name that we had passed into it. Wait, it log.info. Yeah. So the first line was that it logged the request that we had sent, and the logs, as we saw earlier, will be found over here. So this is the this is the log for our request that we just made from the portal directly. And then what it does is it goes ahead, it takes all the query parameters. It checks that if there is a query value provided, then it utilizes that. Otherwise, if it does not find the name in the query string, it tries to read from the request body. Since we are already specifying that we will be having the post requests as well as the get request, so this part of the function works in the get, and this part of the function works in the post environment. So it tries to read the object and get the name property from it. And then lastly, it checks if the name is equal to null, then it will give an error. Please pass a name on the query string or in the request body. Otherwise, it's gonna just return an OK, which will be 200 status request, status for the request, and then a message hello and the name. So if we just see over here, we passed hello, name was Azure, which was the default. Let's change it to Dear Azure and see how it functions. Let's run it, and in the logs, you'll be able to see that there was no new trace in the past 1 minutes, and then we sent a request again, so it was able to tell us that a new like request came, and it triggered the function. And at the same time, if you just take a look over here towards the bottom, you will see that since our parameter now included Dear Azure in the request body, the output was hello Dear Azure. So that is pretty much it. I know it's very trivial kind of example, but it helps us out in developing the application right from the Azure portal. We can debug the application, and we can perform all sort of actions right from the application from the Azure portal. And this was one of the ways in which we can create the function. We can easily integrate different kind of bindings. Like for example, what trigger are we using? We're just using the HTTP trigger. We have to delete the trigger in order to change it, because mostly there's just one way, one input to the function, and the outputs can be multiple. It can generate an output on the HTTP stream. It can also create an output, like for example, if you want to log your data into some other ingestion tool like the IoTs or the queues, you can use this right over here and create a new output for this. Then right at the bottom, you have different HTTP methods that you can do. The reason being that we have the HTTP, all of this setting will come from the trigger. Since we are having the HTTP trigger, it demonstrates that we can use other kind of HTTP methods. We can allow, disallow specific kind of HTTP methods. The authorization level and other different kind of facilities are provided over here. Since I'm not going to use this function, let's just go ahead and see if I can get the URL for this function and have you guys send a request to it as well. Mm, get the function URL, copy, hello function. Is it accessible? Okay, so name, URL. I'm gonna be sending this URL for you guys to try. It will be open for like 10 to 15 minutes, so that you guys can try it out for a while. Please do play around with it, see how it works, when it throws an exception, when it doesn't, so that you guys can understand how your function as a runtime tries to map the objects to the parameters that we're using, and how easily we can have our functions perform the task that we want without having the overhead of a full framework to manage, as well as for the runtimes to support. One thing that I would like to go ahead and talk about is the fact that since we no longer have the scale up feature, how would like for example, if we're having 10,000 of customers and all of a sudden we get a peak like 25,000 or 30,000 users. So how will the application scale? The reason is that since we're using the consumption plan, the Azure platform is responsible for scaling our application. Azure will automatically deduce that we are taking a heavy load of users, and it will automatically add more machines to the framework, and add more instances, and replicate everything on those instances, and then load balance it all by itself. And as soon as it considers like, okay, the load is down, it will automatically delete those resources, and we will not be charged for the instances or for the machines that we're going to use. Whereas in other case, for the app service plan, if we would be going for the app service plan and we scale the application, they will be counted up against as an instance. Whereas in the consumption plan, we are not charged for the scaling for that stuff. We are only charged for the amount of time that our request takes, the resources that it consumes. So that is how basically you write the function app, and you consider these of the elements like the costing, how to write the function, how to remove the dependencies, and how to log them. So these are a few of the things that you should consider while writing the IR functions, and how to write the IR functions. So I believe that's a pretty much wrap from my side. If you guys have any question, since we're also running out of time, we have 4 to 5 minutes. We should definitely consider going for a quick discussion about what we just talked about. And you guys, if you have any questions, please go ahead and hit me with them.
Yeah, hello, Afzaal. This is Santosh Jindal. Just one query from my side. How can we
Mhm.
integrate Azure functions to our existing code? Is it with a URL or something else?
Yeah, basically, like for example, if you mean like you have a mobile application, is that example okay? Like you want to integrate the Azure function into mobile application?
Yes, any example you can take.
Okay. So if like for example you have a mobile application and you want to integrate the IR function runtime into that. So what you will do is basically you will create an API and you will expose that API on the IR functions. Like we just saw, we have one of the get request, we have put request. So any operation that your mobile application has to perform, it can be hosted on the IR function. And since we have already seen that the outputs can be on HTTP. The inputs can come from the blobs, it can come from any of the storage capability. Like for example, if you have some news or articles created on Azure storage, you can read everything from the Azure storage and you can return it in JSON format, let's say, on the HTTP. And that is one of the ways in which you can integrate Azure functions into your mobile application as a web API upfront. I already have an article coming up in a week or two where I talk about how you can lift and shift all of the currently existing APIs, like for example in ASP.NET API or Node.js APIs, and how you can expose them as different functions on the IR function. The benefit will be that individual functions or endpoints will be able to scale separately. They will have little to no dependency on each other, and the benefit that you will get is the cost will be managed effectively, if we see in terms of that. And another thing is that if like for example as in the case of microservices, if one of your function fails or doesn't provide something, you can just go ahead and edit that specific function instead of having to recompile everything, rerun all of the unit testing on the whole of the application and then deploying it all, because a big application comes with with an overhead of size as well. So IO functions are really very tiny. As you have just seen, that the function is just like 20 to 30 lines of code, a simple function, and it can grow to like 40 to 50 lines of code. In Node.js, it's even less than that. So that is a very huge support in terms of writing the function and then integrating the function. As you had just asked, there are several ways. You can use the HTTP request. You can use other triggers. Like for example, if you have .NET clients, you can integrate them via the SDK for the IR function, or you can even do that. Like for example, one of the example I explained was that, for example, your user is trying to save his image from his mobile device. So what they will do is that they will go ahead, they will upload the picture on the IR function, and what your mobile application will be doing is it will not be communicating with the IR function directly. It will be storing the image on the IR storage. On the Once the image goes on IR storage, it will automatically trigger the IR function. So in other words, you just
Oh,
have to think about the architecture of the application, how you are going to trigger the function. That can be via HTTP directly, that can be via another resource, or that can be via other SDK or other approach that you consider viable.
okay, Abdul, thank you.
Okay. So do we have another question?
Uh,
Yes, Sanjay, yes, we can write all the APIs, everything, everything that we had been doing uh, in the web API, like for example, the ASP.NET Web API framework, or in Node.js application, or Python, or anything that is like oriented towards web APIs that only requires the HTTP protocol to communicate over, that can be written as a function, each and everything.
I believe uh,
Mhm.
Yeah, hello, Abdul. There is one more
everyone
query
is
from my side.
Okay,
okay.
yeah, there's a question, Kasam.
Yeah. So if we want to use some external DLLs to our Azure function, so how can we refer them? For example, in Visual Studio, we do it through Nugget Package Manager. So in Azure
Mhm.
function, how can we use those DLLs?
Okay, so mostly Azure provides those DLLs for you, but not all of them. The thing is, like for example, the JSON.NET DLL and a few other similar most widely used DLLs are already available on on the platform, and you can reference them using the CSS file referencing mechanism. It's hash r and then the name of the package. If that is not
You're not
available
audible. Can you repeat again?
Okay, I'm sorry. I was saying that most of the libraries are available on the IR platform, and you can reference them using the standard defined in the CSX file or the C# script file. You can do that like hash r for reference, and then the name and then the package name that you want to download and export. But if that is not available, then you can either then you can like we just saw we have a tab for the files, so
Yes.
you can just upload the file over there, and then you can reference the DLL for. So for example, if you have a custom DLL, your own made DLL that may not be
Right.
available on Nugget or anywhere. So what you can do is you can upload the DLL over there and then reference it directly from using the name of it. So there are different several ways in which you can easily utilize it.
Okay. Okay. Thank you.
Thank you, Raj. I hope you guys learned something out of this session.
So I believe like we are done today, and guys, I will be providing you one URL where you can very well post your queries with regarding to this session, and I will try my best to make it available to the respective speakers. And once they get time to respond, it will be given back to you. Um, and Another thing, like thank you, Afzal. It was an really great session, and thank you for making out this time. I know there was an hectic schedule you were into from the last 1 week, and
No, thank
the
you. You were
yesterday's session about Azure storage, we will plan in somewhere in September, and we will
okay.
update to you all guys. Hope Ahmed, Afzal, you will be like we will be discussing it offline about the dates.
Perfect.
So just a last update, like this session will be again uploaded to our YouTube channel. You can see the link over the screen. That's in it is not clickable, of course, but it is readable too. It's in like if you just go to that AZ-YouTube, you will be going into particular YouTube channel, and I will be, of course, publishing over the groups like once it is uploaded. Another update is for the coming weekend, that is 25th and 26th, we have an session on Microsoft Azure IoT. So it will be everything about IoT, working with IoT Hub, SDKs, and development and all. So do join that session also. And thank you again. Thank you, Afzal, and thank you all who have
Thank you.
joined and given this time. Thank you.
Thank you. Bye, everyone.
Thank you.